Hey there, and welcome back to the Deep Dive.
Hello. Great to be diving in again.
Today, we're tackling a really big one, a pivotal moment, you could say, in mobile history.
Absolutely. We're talking about the rollout and impact of 3G networks.
That's it. And we've got quite a stack of material here, sources focusing on how this third generation of mobile tech really, well, changed everything.
It did. It's not just about faster speeds, though that was huge. It's about how it fundamentally reshaped what a phone was, you know?
Exactly. So our mission, our goal for this deep dive is to unpack that whole era. We want to understand what 3G was really aiming for, the tech that made it tick.
And why it was the turning point where phones stopped being just, well, phones for talking and texting.
And started becoming these incredibly powerful little computers we carry everywhere. Those that basically run our lives now.
Yeah, it's a direct line from 3G to what's in your pocket right now. So we'll look at that jump from 2G. Remember 2G.
Remember 2G data speeds. Painfully.
Yeah.
Pixel by pixel loading.
Exactly. So we'll trace that evolution, get into the specifics, UMTS, WCDMA, HSPA, EVDO, all those acronyms.
But explain what they actually meant for users, like enabling the real mobile web, video calls.
And, crucially, the App Store phenomenon. And we'll also touch on its legacy because, believe it or not, 3G is actually being phased out now.
Right. So yeah, if you remember that slow, frustrating 2G experience, get ready. We're about to explore the generation that smashed that speed barrier and put genuine broadband internet in our pockets for the very first time.
Okay, let's do it. Where should we start?
All right, let's start right at the beginning.
Yeah.
Transitioning from 2G. What was the single biggest problem 3G was really designed to fix? What was its main goal?
That's the perfect place to start, and the sources are really clear on this. 2G was definitely revolutionary for its time.
Sure, digital calls,
Yeah.
SMS, that was huge back then.
Absolutely. It digitized voice, introduced basic data like text messaging, even that early kind of clunky WAP browsing. But, and this is the big but, speed, exactly. For anything beyond a simple text message or maybe a super basic WP page, 2G data technologies like GPRS and later ADGE were just slow. Really slow.
Like dial-up slow, sometimes worse.
Pretty much. The sources really emphasize this point. People were getting used to faster broadband connections at home, maybe DSL or early cable.
Right.
And then they'd try to use the internet on their phone. And it was this sluggish, stripped-down version, as one source puts it. Terribly frustrating.
Yeah, you couldn't really do much.
Not really. So the primary, almost singular objective driving the development of 3G was clear. Deliver much faster mobile internet access, significantly faster.
So it wasn't just about tacking on data features, it was about a fundamental step change in speed and capability for data.
Precisely. 3G was conceived and designed from the ground up with data as a core focus, not an afterthought. It aimed for significantly higher data rates, yes, but also lower latency, that responsiveness you need for real-time applications.
Latency, yeah, that delay. Crucial for things feeling instant.
Exactly. The goal wasn't just a small bump. It was to enable a whole new class of services that were simply impossible or impractical on 2G. Think rich multimedia, proper web browsing that looked like it did on your computer.
Video calling, maybe?
Yes, eventually video calling, complex applications. It needed to feel less like some cut-down mobile internet and more like the real internet, just in your hand.
Okay, got it. A massive leap intended for speed and richer experiences.
Now, achieving that sounds like it needed some serious new technology under the hood.
Oh, definitely.
What were the key technical building blocks for 3G? Especially thinking about the networks that evolved from GSM, which was dominant globally.
Right, so the 3G era saw a big push towards more globally harmonized technologies. And the underlying principles were largely based on advanced forms of CDMA code division multiple access.
CDMA. Okay, I know that was also a 2G technology, kind of running parallel to GSM's TDMA in some places. It was, but 3G used CDMA principles in a much more sophisticated way. Think of 2G TDMA, like in GSM, as people taking turns to talk in a room, you get your specific time slot.
Right, time division.
Yep. Early 2G CDMA allowed multiple people to talk sort of at the same time by using different codes, allowing the receiver to pick out the signal it wanted, like distinguishing different conversations happening simultaneously.
Okay, separating the signals.
3G took that concept much further. For the networks evolving from GSM, and that was the path for many operators globally, like Rogers and Fido in Canada, mentioned in the sources the main 3G standard adopted was UMTS.
UMTS. Universal Mobile Telecommunications System.
Okay. In the core radio technology, the way the signals actually traveled through the air for UMTS was WCDMA.
WCDMA.
Yeah.
The W standing for wideband, I assume.
Exactly. Wideband code division multiple access. And that wideband part is really important.
Why would it being wideband allow?
It meant that WCDMA used a significantly wider channel of radio spectrum compared to the narrower channels used by 2G technologies. Think of it like having a much wider highway instead of a narrow country road.
More lanes, more traffic and flow.
Precisely. That wider channel could carry vastly more data simultaneously. And crucially, WCDMA was designed from the outset to handle voice calls and data sessions efficiently at the same time.
Ah, so you could be on a call and still have your data connection working properly in the background.
Yes, that was a key design goal. In 2G, data often felt like it was squeezed in around the voice calls, and performance could suffer. UMTS with WCDMA aimed for a much smoother integration, treating data as a first-class citizen alongside voice.
Okay, so UMPS using WCDMA provided that fundamental wider pipe for more data. But I remember reading in the sources that something called HSPA was the real breakthrough, particularly for this UMTS pass. What was that about?
Ah, yes. HSPA, high-speed packet access. This is crucial. While UMTS and WCDMA laid the foundation, providing that initial 3G speed bump, maybe a few hundred kilobits per second initially.
Which was better than 2G, but maybe not mind-blowing yet.
Exactly. It was better, but HSPA was the technology that really delivered on the promise of mobile broadband for the masses on that UMTS track. It wasn't technically a whole new generation like 4G would be.
Which is why it got called 3.5G sometimes.
Precisely. You often saw it marketed as 3.5G or HSPA or later HSPA Plus or even just mobile broadband. It was an evolution, an upgrade to UMTS networks.
I definitely remember seeing H or H plus symbols pop up on my phone screen back in the day.
That's exactly what it was indicating. HSPA, and particularly its enhancement HSPA plus Odger, brought about a dramatic increase in actual real-world download and upload speeds. We're talking about moving from those hundreds of kilobits per second up to several megabits per second.
Okay, that's a significant jump. Kilobits to megabit.
It absolutely was. For the first time, you were getting mobile speeds that felt comparable to early home broadband, like DSL or cable internet. Upload speeds improved too, which was important for sharing content.
And that speed, that megabit level speed, must have been what really changed the user experience.
Totally transformative. The sources explicitly state that HSPA delivered the broadband-like speeds that were essential to power the first wave of truly modern smartphones. Think early iPhones, Android devices.
They needed that faster pipe to function properly, to deliver that rich experience they promised.
Absolutely. Without HSPA boosting UMTS performance in the real world, those early data-hungry smartphones, with their full web browsers and potential for apps, would have felt sluggish and frustrating. The experience just wouldn't have been good enough to drive mass adoption. HSPA was the practical key that unlocked that potential on the GSM UMTS side.
Fascinating. So UMTS CDMA set the stage, but HSPA really opened the throttle. Now, you mentioned earlier that CDMA was also a 2G technology path. What about the carriers who used CDMA for 2G? Like Bell and Telus in Canada at the time, according to the sources. How do they get to 3G speeds? Do they use UMTS too?
No, they followed a different but parallel evolutionary path. Networks that started with CDMA technologies for 2G, primarily using a standard called CDMA 2001X for voice and basic data, had their own upgrade route for high-speed data.
Okay, a separate track. What was their technology called?
Their high-speed data technology for the 3G era was called EVDO.
EVD, okay. What does that stand for?
Evolution data optimized, or sometimes evolution data only. The key point is evolution data. It was specifically designed as an overlay or upgrade to provide high-speed packet data on CDMA networks.
And was its role, its impact, similar to what HSPA did for UMTS networks?
Very much so. Think of EVDO as the counterpart to HSPA. Just as HSPA dramatically boosted speeds on the UMTS side, successive revisions of EVDO like Revision A, Revision B, delivered multi-megabit broadband speeds for users on the CDMA path.
So similar speeds, similar goal.
Exactly the same goal. Provide a competitive, fast mobile internet experience that felt like broadband. It ensured that no matter which underlying 2G technology a carrier had invested in, whether it was GSM leading to UMTSH SPA or CDMA leading to EVDO, they had a viable path forward to offer true 3G mobile broadband services to their customers.
Interesting. So two main technical roads, UMTS HSPA and CDMA EVDO. but both converging on that same destination of multi-megabit mobile internet.
That's a good way to put it, converging on the user experience, even if the underlying tech differed.
Did having these two major paths cause issues, maybe with phones working across different networks or when traveling? Or did 3G improve things compared to 2G?
That's a really interesting point the sources touch on. Despite having these two main technological families, 3G actually represented a significant improvement in global compatibility and roaming compared to the fragmented 2G one.
Really? How so?
Because both UMTSW CDMA and EVDO were based on more advanced and in many ways more harmonized CDMA principles. They were also developed with global standards, bodies like the ITU playing a stronger coordinating role. So while you still needed phones that supported the specific bands and technologies of a region—
Like a world phone.
Exactly. The underlying similarities and the push for standardization meant that designing phones capable of operating on both types of 3G networks, or at least roaming effectively between them, became much more feasible than in the 2G era. It was a definite step towards the truly global standards we see with 4G LTE and 5G.
Okay, so two paths, but better signposting between them for travelers. Makes sense. All right, so we have the technology established, UMTS HSPA on one side, EVDO on the other, both delivering these multi-megabit speeds. Let's talk about the impact. What specific game-changing capabilities did this speed unlock for actual users? How did it change how we used our phones and the internet?
Right. This is where it gets really exciting, where the technical potential turns into tangible change. That leap in speed, combined with the lower latency we talked about, unlocked a whole range of experiences that were either completely impossible or just agonizingly bad on 2G.
Like what? What was the first big one?
I think the most fundamental was true mobile web browsing. As we said, 2G had WP, which was very basic, mostly text.
Like teletext on your phone almost.
Kinda, yeah. To 3G, especially with HSPA and EVDO speeds, meant you could finally access the full web. We're talking rich HTML websites, the same ones you viewed on your desktop or laptop, with images, complex layouts, interactive elements.
So the mobile web stopped feeling like a stripped-down imitation.
Exactly. It started feeling like the real internet, just on a smaller screen.
Okay.
That fundamentally changed how people accessed information, read news, shopped, researched everything while on the move. It untethered the web from the desk.
That's huge. What else became possible? You mentioned video earlier.
Yes, video calling. Real-time, person-to-person video calls on a mobile phone became a practical reality with 3G. The sources mention this felt like science fiction not long before.
I remember seeing ads for it. It seemed amazing.
It was. It required both the higher bandwidth to carry the video stream and the lower latency for a smooth, conversational experience. While maybe it didn't become instantly ubiquitous for everyone, the capability was there, it worked reasonably well, and it was definitely a key selling point that highlighted the power of 3G networks and devices.
Okay, full web video calls.
Yeah.
Massive steps. Now, we absolutely have to talk about the smartphone explosion. How did 3G specifically pave the way for the modern smartphone and that whole app ecosystem that dominates today?
This is arguably 3G's most profound legacy. That faster, more reliable, always-on data connection was the essential ingredient needed for complex mobile applications to flourish.
Why was the connection so critical for apps?
Well, think about it. On 2G, downloading even a moderately sized application was slow and potentially expensive, depending on data plans back then. And running an app that needed to constantly pull data from the internet, like maps, social feeds, streaming media, was often impractical due to the speed limitations and high latency.
The apps wouldn't have felt very live or dynamic.
Exactly. They would have been slow, clunky, maybe mostly offline with occasional syncing. 3G provided the stable, fast enough foundation required to download larger, more sophisticated apps quickly and, crucially, to run apps that relied on a persistent, responsive connection to the internet for their core functionality. It created the environment where rich mobile software could actually thrive.
So 3G built the stage, and then the main actor arrived.
Perfectly put. And that main actor arriving at almost the exact right moment was, of course, the original iPhone, launched in 2007.
The timing seems almost too perfect in retrospect. Tell us about that relationship, the iPhone and the maturing 3G networks. The sources call it symbiotic.
It really was. The iPhone landed just as 3G networks, particularly those boosted by HSPA, were becoming widely deployed and robust in key markets. The iPhone itself, with its revolutionary multi-touch interface, its focus on a desktop-class web browser, mobile Safari, and its entire design philosophy centered around a rich internet experience.
You needed 3G to really shine, didn't it?
Desperately. The sources are very clear on this. Trying to use that beautiful web browser or imagining the kinds of apps that would later populate the App Store on a slow 2G ADGE connection, it would have been painful.
The user experience would have been crippled.
Severely crippled, as one source says. It would have been slow, frustrating, and likely would have undermined the entire value proposition of the device. The iPhone's potential was fundamentally tied to having a fast enough network connection.
And conversely, did 3G need the iPhone?
You could absolutely argue it did. 3G offered this amazing potential fast mobile data, but for the average consumer, the question was, why do I need that? Voice and text were understood. What was the compelling reason to upgrade, to pay for a data plan?
The killer app or killer device argument.
Exactly. 3G needed that killer device to showcase its power, to make the benefits tangible and desirable. The iPhone, with its intuitive interface and focus on mobile internet and media, was that device. It gave people a reason to want and use fast mobile data. The source nails it. The device needed the network, and the network needed the device. They created a virtuous cycle, pushing each other forward.
That synergy is fascinating. And then came the next big bang, the launch of the App Store in 2008. How did that event, built squarely on top of these 3G capabilities, ignite things?
If the iPhone plus 3G was the spark, the App Store was the explosion. Launched a year after the first iPhone, in 2008, it leveraged those maturing 3G networks perfectly. The sources credit the App Store with nothing less than igniting the entire mobile app economy that defines our digital lives today.
The entire mobile app economy. That's a huge claim. What made it so transformative?
It did two crucial things. One, it created a centralized, incredibly easy-to-use marketplace for users to discover, purchase, and download applications directly to their phone over the air using that 3G connection. No messing with computers or sideloading.
Frictionless discovery and installation.
Precisely. Two, and just as importantly, it provided a standardized platform and a direct distribution channel for developers. Suddenly, anyone from a large company to a single coder could create an app and potentially reach millions of users without complex deals with carriers or manufacturers.
It democratized mobile software development and distribution.
Completely. And this combination, easy user access, open developable platform, and a capable 3G network to handle the downloads and data needs it, just unleashed this unprecedented wave of creativity and innovation. Games, social networking, productivity, utilities, navigation, entire new industries were born, fundamentally changing what people did with their phones. The phone became a customizable, extensible platform.
It really redefined the device. Okay, so the web, video calls, the whole app ecosystem. Were there other key services that 3G speed enabled, things we might take for granted now?
Yes, a couple more are worth highlighting. One was the beginning of viable mobile media consumption, specifically early music and video streaming.
Streaming on the go. That must have seemed amazing back then.
It really did. Now, it probably wasn't the smooth, high-definition experience we expect today on 4G or 5G, but 3G speeds made it possible to start streaming audio and even standard-definition video without necessarily downloading the entire huge file first. You could listen to internet radio or watch short video clips. It opened the door to on-the-go media in a new way.
Planted the seeds for Spotify and Netflix on mobile, essentially.
You could definitely see the lineage.
Yeah.
The other major area was location-based services.
Maps and navigation.
Exactly. GPS chips were becoming more common in phones around this time, but GPS just tells you where you are. To make that useful for navigation, you need map data, points of interest, maybe traffic info.
And that data needs to be downloaded.
Right. The faster 3G connection was crucial for downloading map tiles quickly, getting real-time turn-by-turn directions, searching for nearby businesses. It made mobile mapping and navigation apps genuinely useful and responsive for the first time, transforming how we find our way around. Combining GPS with fast mobile data was a killer combination.
Okay, so mapping, early streaming, video calls, the full web, and underpinning the entire app economy. That's a huge list of achievements. Thinking about its overall impact, looking back, what would you say is the single most critical, enduring legacy of this 3G generation?
If you have to boil it down, the sources strongly suggest the most critical legacy is that 3G provided the foundation of the smartphone revolution.
The foundation, not just a feature, but the bedrock.
Exactly. It was the essential enabling layer that allowed the mobile phone, primarily a communication device, to transform into the powerful, pocketable, always connected internet gateway that sits at the center of modern life. Every smartphone today, regardless of brand or OS, is a direct descendant of the capabilities that 3G first made possible and practical. It fundamentally changed the trajectory of personal technology.
It shifted the paradigm from communication device to computing platform.
Perfectly said. And tied directly to that, its second major legacy, which we've discussed, is being the creator of the app economy. The sources call this a multi-trillion-dollar global industry, and it simply would not exist in its current form without the fertile ground prepared by 3G networks, the speed, the platform enablement, the user adoption it fueled.
Astounding economic impact, really.
Yeah.
Now, how did all this success, the apps, the constant connectivity, the changing user habits, how did 3G then influence what came next? How did it pave the way for 4G?
It's a classic case of success breeding new demands. 3G didn't just deliver faster internet, it fundamentally changed user expectations.
Oh, so.
Because of 3G, having fast, reliable internet access on your phone stopped being a novelty or a luxury feature. It became the default expectation. People got used to browsing, using apps, streaming media, navigating on the go. It became embedded in daily routines.
Once you taste that speed and capability, you don't want to go back.
Never. And what happened was the very success of the things 3G enabled, particularly the explosion of the app economy and the rapid growth in mobile video consumption, started to push the limits of 3G networks.
People wanted more, faster.
Always more, always faster. The sources talk about an insatiable public appetite for even higher speeds and even lower latency, driven by these increasingly sophisticated apps and data-hungry services like HD video streaming and more complex mobile gaming. People were doing more and more demanding things on their phones, and they wanted it instantly, flawlessly.
So the demand created by 3G's capabilities essentially necessitated the next step.
Precisely. That huge, user-driven demand for better, faster, more responsive mobile data directly drove the development and deployment of 4G LTE. 4G wasn't just a research project, it was a direct response to the world that 3G had created, aiming to deliver significantly more capacity and speed to satisfy the demands 3G itself had unleashed.
Fascinating. The child outgrew the parent's house,
Right.
essentially. Okay, let's bring this right up to the present day, June 2025. We mentioned 3G is being phased out. What's happening to those networks now, and as it fades into history, how should we really remember 3G's contribution?
Yeah, it's the end of an era, quite literally. As we speak, 3G networks are indeed being decommissioned globally. It's often referred to as the 3G sunset, just like 2G networks were largely shut down before it.
And 3G's time is now coming to an end.
It is. Many major carriers across the world, including those mentioned in Canada, for example, have either already switched off their 3G services or are in the final stages of doing so right now.
And why are they shutting them down? Is it just obsolete?
It's primarily about spectrum efficiency. Radio spectrum, the airwaves used for mobile communication, is a finite and incredibly valuable resource. 3G technology, while revolutionary in its day, is far less efficient at carrying data compared to modern 4G, LTE, and 5G technologies.
Newer technologies can pack more data into the same amount of spectrum.
Vastly more. So carriers are shutting down the older, less efficient 3G networks to refarm that valuable spectrum. They're repurposing those radio frequencies to be used for their 4G and 5G networks instead.
So freeing up the space to boost the performance of the networks most people are using today.
Exactly. It allows them to improve the speed, capacity, and overall performance of 4G and 5G, which are essential to handle the massive data demands of modern smartphones, streaming, gaming, IoT devices, and everything else. It's a necessary step to keep improving the mobile experience.
Makes sense. So as 3G rides off into the sunset, giving its spectrum to its successors, how should we ultimately remember it? What's the final thought on its place in history?
I think the sources capture it well. We should remember 3G as the truly pivotal generation. It was the crucial bridge. It connected the old world of mobile, focused mainly on voice calls and simple messaging on feature phones, to the new world of mobile computing that we live in today.
The bridge generation. I like that.
It wasn't just an incremental step. It was the fundamental enabler. It was the technology that, as the sources conclude, truly and irrevocably put the internet in our pockets. That's its enduring legacy.
Wow. Put the internet in our pockets. That really sums it up.
So the key takeaway from this whole deep dive seems to be 3G wasn't merely a speed bump. It was the foundational layer that enabled the entire smartphone era and kickstarted the multi-trillion-dollar app economy.
It completely changed the game. It redefined what mobile meant. Absolutely. So thinking forward, as we see this 3G spectrum being refarmed, as these older networks disappear, it makes you wonder, doesn't it? Our reliance on always-on, super-fast mobile data is only growing. How does that relentless demand continue to shape the future? What kinds of innovations might seem impossible, even on today's 5G networks, but could potentially be unlocked by whatever comes next. 6G, 7G, just like 3G, unexpectedly opened the door for the App Store and mobile video.
It's a fantastic question to ponder. The cycle continues. The capabilities unleashed by one generation inevitably create the demands that drive the next. What seems like science fiction now might be commonplace in a decade, thanks to the network underneath.
Always reaching for the next frontier. Well, that feels like a good place to wrap up our deep dive into the incredible story and legacy of 3G. Thank you so much for guiding us through that history.
My pleasure. It's fascinating to look back and see just how profoundly that one generation shifted everything in the mobile world. Hope everyone listening found it insightful.
Yeah, hope you enjoyed that journey back in time and see the connections to today. If you did find this deep dive interesting and you want to keep exploring technology, its history, its future impact, all that good stuff, please do remember to subscribe to our channel, Tech AI and beyond.
You can find us wherever you get your podcasts. Subscribing is the best way to make sure you catch all our future deep dives.
Absolutely. Thanks again for tuning in.
Until next time.
See you on the next deep dive.